next up, we have Timeplus. Michael, are you there?
Yes, sir, I am.
Excellent. So Timeplus is the newest, and it seems to be moving and changing direction so fast I can't keep up with what it's doing. To me, what was most interesting about this was the integration and the unified platform, where you seem to be looking at the whole problem of streaming the database, even all the way to the UI. Um, Actually, one thing I should have mentioned at the start for the people call, we were not paid in any way by these vendors, as you may typically find in some of these calls. We're trying to remain absolutely neutral because currently Pulse is our focus. Time Plus, for example, does not even work with Pulse, so we're as neutral as possible. I was just excited by the platform because of the unified nature. So I'm interested to see what you're now doing. With that, over to Michael.
Sure. That's a great setup. I'll just wait to start sharing. It's actually, Ryan, you put me in a great place after Quest and Dolphin and ClickHouse. And I took some notes just to kind of say, where does Timeplus fit within what you've already seen? So we're open and cloud-based, very much like QuestDB. So we've got a data engineering UI. Like Dolphin, we are addressing that kind of combined, like Brian said, the stream and batch processing. Ryan, if you could stop sharing, I'll share mine. And then ClickHouse, we are very much like Apache 2.0, SQL-based, and a columnar store. And we also have some more detail I'll get to in just a bit. But so I'll dive right into my presentation. I'm going to step back a little bit from kind of the specifics and just go into the common data architectures that we've seen. I won't spend too much time on this because I know we're a little bit over. Talk about some of the open source building blocks that are out there now that we're seeing a lot in the market, and then kind of where Timeplus fits in, very much what Ryan was just saying. So, I mean, this is the classic, data warehousing, batch processing, loading up an OLAP server to get to a point where you can have some sort of analytics, right? This is what we've seen for 40 years. Raw data sources come into a transactional database that gets batch processed into a data lake or data warehouse for OLAP processing. And recently, there's been some of these hyper translytic analytic platforms that come in. This is the pattern that we see most often, though, where you've got a stream processor loading up data as it arrives and putting that into a table. This is very much that Beam architecture, Flink architecture, where you've got unified access to data from SQL that happens to be data in motion and data at rest. And then you put that back out to a stream processing platform, put that into some system that a UI can take a look at. So I'm going to, again, not talk about Timeplus, just talking about open source architectures and fill in the blank for these kind of blocks with any of the proprietary vendors who might be out there. So you might have a market data LP or something where you're loading into an event stream. Kafka is a logo there because it's becoming more and more popular. Insert your favorite event stream processing platform. And then you have a stream processor. This would be, oftentimes you see Flink coming in, so that's the logo there. And then it goes back to the event stream platform out to some sort of data warehouse, data lake, or OLAP system. So you got Druid, Pinot, ClickHouse, and Iceberg as a format. So that's a pattern we see quite often. That's a reference architecture. And what Ryan mentioned is what Timeplus brings is kind of which parts do I circle and put into one box. So you've got a one-stop shop. What we looked at was the stream processor and the kind of OLAP system are isolated. And oftentimes these arrows are accurate and you're essentially just writing only, going from something that you're working with in real time back out to the stream platform over to some storage unit. And you can't leverage the historical insights you've got from your historical data store in the stream processor itself. The analytic client is pretty much accessing data from here. Pulse and others are able to kind of plug into places to see the data come more live, but this becomes kind of a gap, a stream store gap, where any kind of access that is hybrid, any kind of unified access is flipping between different tools when it comes to scale. And you're also not easily querying it just from one language like SQL. So you've got these real-time analytic tools that are kind of customized for this. They're not necessarily talking over on the left-hand side here. And the question becomes, well, can I take all of this section here and kind of put it into one box? So can I simply take all of the streaming processing, all of the OLAP, and get it into one place where I can visualize everything? very much like this little example here where I can see things moving with simply one query. I'll go more into that in just a bit. Stepping back one little bit more, this is looking at stream processing over the last 30 years or so. So you've got the first generation, a lot of this came out of academia. You've got the second wave, second generation, a lot of this was vendor or large companies that like LinkedIn and others that needed to create something and then open sourced it. So you see a lot of the increased scalability, you see a lot of being able to use stream SQL as opposed to proprietary languages, et cetera. You can fill in here Flink and Beam and Samza and the stuff that came out of Google and everything else. And then finally, you see the kind of this third generation, which is the best of both worlds. Like Ryan said, all of it in one box, right? So you've got that coming into play, especially when more hardware is coming on, and this kind of increase of data that we've seen for a long time. So now on to Timeplus. So this is kind of the vision that we've got, the ability for data to come from wherever, stream into one place where you can then do SQL-based analytics across live data, historical data, essentially seamlessly. And the way we do that is our open source Proton core. So like I mentioned before, we are open sourced, open core as well. That project is called Proton. And we have a stream storage unit, and we have historical storage, which is based on ClickHouse. So everything you saw Robert present, to a certain extent, comes into play here. So the kind of high performance scalability that is built into our platform, and we've kind of circled all of that with a larger platform for analytics and streaming data. So if you were to go to our GitHub repository, this is the architecture diagram you'll see, where we've got, again, a unified SQL, SQL with a streaming extension. So somebody mentioned, or Ryan, you mentioned earlier doing XBars, right? So if you wanted to query our stuff, you could do a tumble or you could do a session window. You're essentially parameterizing the window that you want and then grouping it and joining it and doing whatever else you need to via SQL. So data ingest framework comes into our native log. Again, this is the stream processor. Things are stored out into the historical data store for durability and persistence within, so we're a third generation within the aggregations. And then you can do the batch and streaming reads as you would expect. Right now, we support a lot of different external data sources. So Kafka, Pulsar, so that includes Confluent and Redpanda, Stream Native. We're getting more support for other Pulsar players and other kind of cloud vendors as well. So that's that. And I'll do it. I can run through a demo if you want, but I'll just show you a couple of quick examples. If you were to go to Robert's demo, you're probably going to see this sort of stuff where you're doing a query and you're seeing, you know, on this is on my laptop, 21 million records per second. I'll just do it real quick. So what I'm doing is I'm doing an as of join between quotes and trades. I'll go ahead and run that live. This is on MacBook Pro from a couple years ago, and I'm knocking out 21 million records a second. This can obviously go up as you start to scale. I haven't done anything. And oh, by the way, this application that I'm running, M1 Proton, that's just a single binary release. You can go to our GitHub repository and download. So if you want to try this out on your own Mac, go ahead, knock yourself out. I'll throw in the create stream statements as well, so you can actually run this.
Sorry, Michael, we see your other screen, I believe. So we still see the presentation and not the demo.
Okay.
Maybe.
Well, I'll come back to that after I share the demo then. But if you can imagine the screen that you saw not moving, but 21 million records, and I'll get that to work in a bit. And then this is a small sample of the UI. So if you were to go to the Timeplus free trial, and again, yell at me if you don't see the screen. I'm just doing a silly weighted index calculation against the New York taxi cab data set. So I'm saying grab a few values and then, you know, multiply it by some coefficient and add it up to get a fingerprint of quote unquote some kind of health of the data set. But the bottom line is I'm running half a billion rows in about 35 seconds. So that's getting up to, you know, again, in the 10, 15 million row per second count. Last thing I'll show before I think I hit my time, we do have this UI where if I look on the left here, right, I can create new data ingest pipelines. I can run arbitrary queries and visualize them on a scratch pad. I've got the ability to do views and materialize views, sync any data that I've got from a stream processor back out to an event platform for later downstream digest. I've got user-defined functions. Dashboarding, I can create something here where tables and graphs and geomaps and everything else, I can visualize the data. I can see the data lineage. So you can imagine if you wanted to see how the data went from point A to point B, what calculations were done, what SQL queries ran against which stream when, you can do that, or the lineage against the materialized view, and then alerting as well.